Welcome everyone to lesson 3.5 of calculus, which is all about sinusoidal functions, which sounds like a new thing, but it's really just modifications of the sine and cosine functions we talked about last lesson. Let's get started. Any transformation of the sine function is called sinusoidal. What about cosine? Well, cosine, I've kind of got it down here. Cosine is just a horizontal translation of sine. We can see that if we translate sine to the left by pi over 2 units, we will get the cosine function. And conversely, you can also shift the cosine right pi over 2 to get the sine function, so on and so forth. But sine and cosine are translations of each other. So even if we're using cosine, it's still sinusoidal because cosine is a translation of sine. Fantastic. Going off of more properties of functions, we can say that sine has odd symmetry because this S-shaped curve, when it gets repeated, is going to have rotational symmetry around the origin, where cosine is even because it's going to have reflectional symmetry across the y-axis. Then we have this. So our the most basic transformation that we can do on the sine or cosine function is we can give it a vertical dilation. We can give it a coefficient of a. So with that in mind, we're talking about curves that repeat these periodic phenomena. So we're going to use a lot of language that goes along with periodic phenomena, like waves, like sound waves or light waves that you might have heard of before, or even used in a science class. We're going to use some of those vocabulary together. So the amplitude of a sinusoidal function is half of the distance from the middle or the midline to the max value or the min value, or it's half the distance between the max and the min. So if I look here, the amplitude of a default sine function is 1 because that distance is 1, or the distance here is 2 and half of 2 is 1, so its amplitude is 1. Same thing with the cosine. So the default amplitude is 1, but if I multiply the function itself by a constant, the absolute value of that constant is the amplitude. So it doesn't matter if it's flipped or not, the amplitude would still be a positive number. The midline, the middle, remember I was going, sine is middle up, middle down, middle. The middle is 0 by default. We can vertically translate it up and down, but by default, if we don't do that, it's 0. The period, by default, is 2 pi. Period, again, being the shortest amount of time for the cycle to repeat itself. For sine and cosine, that default is pi. And another one of those wave words is frequency. Frequency is how many complete cycles happen within a single radian. That sounds really complicated. Whatever your period is, it's 1 divided by whatever the period is. So by default, it would be 1 divided by 2 pi because the period of sine and cosine is 2 pi. Not bad at all. So let's find the amplitude, zeros, and max and min values of some sine and cosine functions. So first of all, I want to note we are not dilating this horizontally or translating it horizontally, so our key points are going to stay consistent. So the period, if we're not shrinking it or expanding it horizontally, is going to be, so the period, let's just say p. Let's make it easier on myself. P is equal to 2 pi. Great. The amplitude is the absolute value of the coefficient, 3. Now we can use our key points. Remember for sine, it was mid, up, mid, down, mid. So we're going to go mid. Actually, let me use a nicer and brighter color. Let's use like a reddish pink. Mid, up, mid, down, mid. That is the pattern, right? And we're starting and stopping at the length of our period. So this is the curve might help if I would actually hit the point. This is the curve we get. We can repeat the same pattern backwards. So we went up, so we're going to go down, mid, up, mid. That looks awful. Let me try that one more time. You get the basic idea. So we've got this, and it's repeating. So we got the period, we got the amplitude. It wants the zeros, and it wants the max and min values. So the max is 3, and the min is -3. And again, since the same values, it wants the y. The zeros are happening at 0, and it seems like every whole pi before and after 0. So we're going to say the zeros are k times pi. They're happening every pi, and k, we're going to say that k is an integer. This just means we're getting a 0 every whole number value of pi. So 0 pi, -1 pi, -5 pi, all still work because they're all integers. That's essentially it. I think the zeros is probably the hardest part of this whole thing. Let's do cosine now. The period is 2 pi by default. The amplitude is the coefficient, the absolute value anyway, which is 2. From this, we can actually draw the cosine. Remember, the cosine is up, middle, down, middle, up. So we are going up, middle, down, middle, up. And we can repeat the pattern backwards. So up, middle, down, middle, up. And we can actually draw some sort of crude looking cosine graph. So from this, let's figure out the other information. Well, the max values are 2, and the min values are -2. Pretty simple right now. The zeros are happening where there's a denominator of 2. So how do we write that one, Mr. Whaley? Well, the zeros are, well, they're happening first at pi over 2. And then if I think the space between these is all pi. So pi over 2 plus k pi, for k being an integer. You can make that, grammatically make sense later, but k is an integer. What happens with a negative coefficient? Well, the period is 2 pi. The amplitude is the absolute value, so it doesn't care. Let's graph it now. So this is sine. So sine by default is middle up, middle down, middle. Since we have a negative coefficient, we're reflecting it vertically. So where I go up, we're going to go down, and where I went down, we're going to go up. So this sine graph is going to go middle, down, middle, up, middle. So let's graph it. 0, down, 0, up, 0, or middle, right? We can do the pattern backwards. So instead of going down, we're going to go up, middle, down, middle, and we get this curve here. I'm doing my best here, I'm sorry. Oh, it did not like that. Let's bring that back. Thank you. Max and min values, also easy to see. We have a max of 2 and a min of -2. So those are the same, even though the amplitude or the coefficient is negative. The zeros are also the same as the zeros for this sign. The zeros are k times pi, where k is an integer. And last but not least is this -4 cosine. So we already know that the period is equal to 2 pi. We know the amplitude is going to be 4. I can already say that the max is going to be a 4 and the min is going to be a -4. And it's going to have the same zeros. But I'm going to show you a quicker way to write it, more mathematically proper. Let's not go mathematically proper. It's a mathematician way of writing it. So cosine, remember, is up, middle, down, middle, up. Because it's a negative coefficient, we're going to be flipping it vertically. So instead it's going to be down, middle, up, middle, down. So let's do that. 1, 2, 3, 4. Middle, up, middle, down. And then reflecting it because it has that symmetry. So we're going to get what's going to look like a very big M. Nope. There we are. So what is this easier way of writing zeros, Mr. Whaley? So we can say that the zeros are pi over 2 plus k pi. And to say k is an integer, we can actually say k, and then we can use this like weird C with a dash in the middle, and then a double back to z. So this symbol means is an element of, and the capital Z here is the set of integers. So this is saying that k is in the integers, which is the exact same thing as what we've been saying with English. So it's not more proper, it's not anything like that. It's just using pure math notation to say the exact same thing. Did you have to know that? No, but wasn't it nice? So last but not least is, can we find the midline and amplitude given the max and min values? And we can. So what we're going to do, and maybe you'll help me figure this out, I'm going to add the 2 and then subtract the 2, and then divide them by 2 and see what happens. So if I do 100 plus 20 divided by 2, and then do 100 minus 20 divided by 2, I get 120 divided by 2, I get 60, and I get 80 divided by 2, which is 40. Which one seems to be the middle, and which one seems to be the distance from the middle to the max value? If you said that y equals 60 would be the midline, and that 40 is the amplitude, you would be 100% correct. So we add them for the midline, and we subtract them for the amplitude. And if you don't remember, do what I just did there. I didn't use a fancy formula. I wasn't like, we're going to find the average of these two things. Use what makes sense. Make it make sense to you, right? So 135 plus 90, and then 135 minus 90 over 2 over 2. Not as easy to do in your head. So 135 plus 90 is 225. Half of 225 is 112.5. And then 135 minus 90 is 45. Half of 45 is 22.5. So what is this? This is y equals is the midline, and then this is the amplitude. Not bad, not bad at all. If you have any questions about sinusoidal functions, make sure you ask. We're going to do more manipulations of sinusoidal functions in the next lesson, so look forward to that, and I'll see you there in the next lesson.